And we are live. There we go. Wim Dijkgraaf here, CEO and founder of Quotation Factory, with another live stream related to smart factories, often in Europe called Industry 4.0. I will stop trying to use that terminology, Industry 4.0, because of the political connotations that it has. So I try to use the word smart factory. And smart meaning then that manufacturing has the goal to become an autonomous working process, meaning that we have all kind of intelligence in the factory that is able to make autonomous decisions. In order to be able to reach to that point, it's really critical that we implement an event-driven architecture. That's what I've been talking about a lot the last 5-6 live streams, as well as in a podcast that I have here on my iPhone. I was invited by the Smart Metals podcast. So if you search for Smart Metals podcast, for example, on Spotify, or for example in the podcast application on your iPhone, then you will find the Smart Metals podcast and then the episode named Event-Driven Architectures and the Unified Namespace in Metalworking with myself, Wim Dijkgraaf. 44 minutes of, I think, high-value information, just for free. And to make sure that it is clear for our audience that we don't only talk about it, but we actually know what we talk about because we do it, I have invited someone from our customer success team, Lenn Hoek, who will join me in a minute or so from now. Just to be clear, why from the perspective of Quotation Factory, we think it's critical to implement an event-driven architecture. What we as a platform do, in essence, is we have a lot of AI that recognizes the features of a product, such that a metalworking company knows what it is that the customer asks for without needing a lot of time to analyze that and without a lot of time and experience needed from employees. So that's one important ingredient. Then the other important ingredient is that we estimate we do three types of estimations. We estimate production times in the broadest sense of the word. So that's not only the main manufacturing steps, but that includes loading the machine, unloading, setup, programming, packaging, transportation. So every activity and detailed activity we estimate. Then the second is estimate. We estimate material usage. We have specific estimation logic for that, as well as full-fledged nesting algorithms on the platform, both for length material as well as, for example, 2D sheets. And then the third type of estimation that we do is lead time. In other words, the amount of, for example, days, the minimum amount of days needed to be able to deliver it to the customer. So those are three critical ingredients from the perspective of profit margins. So if you estimate wrong, then it immediately has effect on your profit margins. Secondly, if you estimate wrong, then probably you will not be able to deliver as promised. So for the price as promised, or on the day that you promised. And the estimation process is the basis for the rest of your whole production planning. So in our vision, that's the most critical thing if you want to move towards a digital factory or a smart factory, that you give enough focus on understanding what your customer asked for, as well as getting your estimations as realistic as possible. So that's mainly what we solve. Now, related to estimation, since the latest release, we don't have only the ability to estimate, but also to create a feedback loop, meaning that the CAM systems can be used to simulate the process, and the simulated production time can be sent back to Quotation Factory in order to be able to analyze or determine the differences between what has been estimated by our platform versus what the CAM system thinks that setup and production times are. And thirdly, and that's what this video will be about, we are able to connect with the actual machine and obtain actual production times and feed that back into the Quotation Factory platform. The whole idea is that you can look at the differences between estimated, simulated, and real production times, and use that information in order to optimize the reliability of the estimators. Well, we have done a lot of proof of concepts internally already for a couple of years. And our customer success team is involved in this as well. So they are playing with things like Arduinos, with Raspberry Pis, with MQTT, with OPC-UA, etc., creating dashboards in Asana, things like that. And this video is about showing that without a lot of development experience, you can obtain a lot of knowledge, as well as ideas and inspiration with the open source and freely available tool set that we have nowadays. So in order to present that, I have invited Lenn Hoek, Lenn Hoek van Dijke, one of our customer success specialists in the team of 5 people that on a daily basis help to create as much impact with our customers as possible. So Lenn, let me add you to the stage, and there you are.
Hey Wim, thank you very much for the introduction.
No, thanks. Anything to add as part of the introduction?
No, maybe a little bit about my background. That might be good. So working now for 1 year at Quotation Factory, as Wim already said, in the customer specialist team, or customer success team as a customer specialist. I have experience in sheet metal manufacturing at a supplier, where we delivered mono parts to customers with sheet cutting, sheet bending. And before that, I worked at Trumpf for 4.5 years, but more focused on additive manufacturing / 3D printing. And I did my studies in business management and process optimization. So I'm more on a practical level of focused on process and process optimization, and not as much on coding, developing, more in the IT level. So I think that's good to address also, because as Wim already said, hey, we're trying to show people what you can do with a low level of experience related to information technology. So
exactly,
that's about it.
So you are the ideal example. And what I mean with that is that most of our customers, which are metalworking companies, they often don't have an IT department. They sometimes even hate ICT. They like more their machine than the underlying software often. But of course, that holds you back if you look at digitalization and digital transformation, etc. And also the whole vision of an event-driven architecture, which is kind of something, abstract, and it's not easy to understand the actual business value of something like that. So you are the ideal example to show that without a lot of costs, but with, determination, you can come...
And energy.
You can get there.
Yep.
Yeah,
definitely.
Okay. Well, the stage is yours, Lenn.
Good. So I made a short presentation. Wim, I'm not sure if you can share my screen with everybody. That would be good, I think.
I think you can do that yourself.
Oh,
if
perfect.
I'm not mistaken.
Give me a second. Let me see. Yes, present. And then we're going to share my screen. just gonna do screen number 1. And if I'm correct,
I will add it now. Remove our logo. Yes, there you are.
Perfect. So, as Wim also said, we want to show people what you can do with a low level of expertise in IT. So I got the open assignment from Wim to get a better understanding of concepts like smart manufacturing, event-driven architecture, and unified namespace, and also a little bit more in depth for using different protocols and standards within those elements, like ISA 95, MQTT, and OPC-UA that some of you might have heard of. And if not, hopefully this session will also give you a little bit of practical insight of what it does and what it can do. So that was the start why I and what we did. So let's go to the next one. So what did I do? I think Wim asked me, hey, try to take a use case that is related to a practical challenge of our customers and do something in related to that event-driven architecture / smart manufacturing. And due to my relationship with Trumpf in the past, I was interested in machine monitoring. So, and at my time at Trumpf, we already passed the OPC-UA standard multiple times during my time there. So I was also more interested on the technical parts of this standard. And I was like, hey, let's do something with machine monitoring, specifically OPC-UA. And I wanted to do something in regards to part and program time, because in my work at Quotation Factory, we are slowly trying to move towards a closed loop system, but I think we'll discuss a little bit more about that on the end, or a different stream. So the other parts of the challenge that Wim gave me was, hey, try to use the open source software that is available to get to a point of an event-driven architecture and using OPC-UA to make a visible insight of what that machine is doing. So,
yeah, Len.
Yeah,
I asked for open source because what we often see is that, for example, Trumpf has an out-of-the-box solution for this, LVD as well. There are a couple of suppliers of machines and CAM systems that added this event-driven technology infrastructure as part of their software portfolio. But we often see and hear back from our customers that it's such a critical aspect of their business that they would like to see a vendor-independent solution, such that they don't have a huge lock-in, or such that they are free to add whatever machine or hardware that they want to add without a discussion with the brand or the vendor for that. And the beauty is, I think, that there is a lot of open source for free, and quality-wise, it's absolutely at a very high standard.
definitely.
Okay, continue, Len.
Definitely. So how did I do this? As I already said in the beginning, my know-how in regards to programming and IT is quite limited. Yeah, it's more about using, but never about coding or developing. It was in my past. So other than that, I also have limited know-how about electronics, sensorics, and microcontrollers. I have medium to high level know-how about MES, ERP, CAD/CAM, and software architectures due to my past. But more about using it and enabling process optimization than developing it. So next to that, I used a lot of tools that are upcoming the last few years, like ChatGPT and of course Google, due to the accessibility of information. And ChatGPT enabled me, and this was really something that made me very enthusiastic, that there was no need to really learn all the depth about coding, because I'm always a guy that wants to bring it to practice and not study hours and hours before getting something done. So this was a perfect tool because ChatGPT can write code and understand like these open source software tools. At least when you're using correct promptings, it can really give a valuable output that can bring you from a very limited amount of knowledge to a practical solution in quite a short time. So, and next to that, I use a lot of open software tools for transferring, manipulating, storing, and visualization of data, which we're gonna see right now. So how did I do it? I used an open software architecture, which was freeware based. And the benefit of this freeware as the stack I'm using, which is below that, the Ming stack, it has a very large user base. So there are a lot of people that are discussing these open source technologies, what you can do about it, make tons of examples. And what was also really nice to see is that there are also quite a lot of industrial cases. So this is not only limited to hobbyists and people playing around in their basement, for example, but also real life industrial cases where the power of this technology is really shown. So I bumped into the Ming stack, which is one of, I think, the most used free and open source stacks that there is currently, which a large user base, which the Ming stands for Mosquito, Influx, Node-RED, and Grafana. And what it does is that Mosquito is a broker, so it parses data around, basically set InfluxDB that acted as my database and storage, Node-RED, which acted as a, how do you say, a frame in between those applications to connect, to transform, and to parse information. And we have the G in the Ming, which was Grafana, or is Grafana, which acts as data visualization tool. And next to that, I also use some other software tools like MQTT Explorer, Integration Objects OPC-UA client, and a Trumpf OPC-UA machine simulator. And this was also that started a little bit of my journey, because during building my use case and searching around, I found that on the Trumpf machine tools and laser technology IoT GitHub page, there was actually a OPC-UA machine simulator, which actually simulates 2 days of practical data gathered in a real life factory. So I think it's good that I'm going to discuss a little bit more on what I built and how the information is parsed and shown. And then after that, of course, really show the practical example that I built, because that speaks more than some images. So as you see on the OT side, so more of the operational technology side, the first block is the simulator, which I also discussed, that I got from the GitHub page from Trumpf, which simulates the 2 days of data of that specific machine, the TrueLaser 1030. And it simulates the events that are parsed by the OPC-UA server that is integrated in that machine. So it parses out a lot of events. We can look later on in the namespace of that OPC-UA simulator. So it parses events like start stops, part times, program names, etc. And these are all parsed by OPC-UA, which is a specific open communication standard, which is a lot used in industrial setups and manufacturing. Then I had on the edge, I have an edge device. So on the edge, it's very close to the system, on the edge of the OT system where it goes to IT. I had an edge device. In this case, I have a, how do you say, a micro computer that is taking this OPC-UA information, and I'm using their Node-RED to transfer that OPC-UA data to MQTT. And MQTT is then a message that I'm parsing to Mosquito. And Mosquito is an open source broker that can is a pub/sub based system. So I am parsing a certain element of data onto the broker. And if I have on the other side a subscriber that is subscribing on that specific topic, because I'm parsing data on a topic, when that topic changes and the state of that node changes, this is then picked up by the subscriber. So, and the benefit of this is that it is only reporting by exception. So whenever that state is changing, the subscriber is picking up. And so that's not constantly parsing data every second, for example, but only when it changes, because this is important, because you only need this information when the state change. You don't need to know every second that, for example, the temperature is 30 degrees. You want to know when it changes from 30 to 31, for example.
Yeah. Len?
Yeah.
So that means you don't have the laser machine in your home. You use
No.
a simulator.
Yep.
That simulator simulates the working of that sheet cutting laser machine.
Mm-hmm.
That sheet cutting laser machine in reality also has an OPC-UA server on board. That means that just with a network connection, you can reach that OPC-UA server. You run Node-RED on the edge device, which, for example, can be a Raspberry Pi or another type of microcontroller. Often those are very cheap devices with sufficient capacity in order to do the job. And in Node-RED, you created something that becomes that connects with the UPC-UA server, so it becomes a UPC-UA client that observes the machine, and it also connects to the Mosquito MQTT broker as a client. So it's a client of two worlds, and then you convert what you observe in the laser machine to an event or a message on the Mosquito broker. And because of the topic structure that you are going to show, the outside world knows that this is about that specific laser machine.
Yep. Yeah, I think it's good that we might show a little bit of the software underneath and it's running, and then go back to this image to get a better understanding of the total flow. Yep. So first of all, as you'll see, I have so what you see running now, it's the Trumpf servers, or the Trumpf 1030 simulator, which is simulating all the events, and you're seeing that it's constantly sending those events out, or it's creating these events in the OPC-UA server.
Can you give just a couple of examples of events that it simulates?
Yeah. So and I can also show you the namespace, which have a little bit more detail, because you just see the server running. But what I did, this is a client, and I can connect to that OPC-UA server to really see the structure of events that it's giving. And for example, so you see the true laser system, and let's check out some events. For example, under the operation status, we have under the status, we have, for example, it's active, it's interrupted, it's ready for use, or it's in the startup phase. Yeah. In regards to, for example, the part program, you have the name of the part that is running, and also the state of the part that is cutting. So from running to, for example, ended, or stopped due to the fact there was a malfunction, or an operator intervention. But you can also see, for example, the technology tables which it is using to cut with, what kind of material it's cutting, what the size of the sheet is that is currently being cut, etc. So I searched for all these events and I said, okay, I want to pick them up, parse them into a new standard from OPC-UA to MQTT. And that I have done with Node-RED, which I will show you now. So
yeah, just for the listener, Len, what we actually implicitly did is we said every machine has its own protocol. It can be OPC-UA. Some machines have MT Connect. Others already speak MQTT. So there are a whole lot of different protocols depending on the preference of a supplier. But in our factory, we want an event-driven architecture based on one standard protocol that in this case is MQTT.
Exactly, Wim. That's a very good addition. And because it also really benefits in the unified namespace by structuring these topics, also making it, so to say, understandable for everyone, because the data is parsed on specific levels in the enterprise and therefore quite transparent.
Exactly.
So what I did is, as you see, I have all these topics, as I showed already in the namespace of the OPC-UA client. And I'm, of course, needing to connect to the client to the endpoint where all this data is generated. And I'm then using a report by exception node, because currently I'm just pushing the system to get an information point every second. So even if the state is not changed, I'm still pushing it to get that data. But then I'm only reporting it to MQTT when its states change. So therefore, report by exceptions, RPE. And then I'm pushing that specific data out under a specific topic in my specific namespace. The highest level is my machine, and the sublevels are the points of data that are underneath this part of technology. And to see how all that information is parsed towards Mosquito, I can show you how that looks like by using the MQTT Explorer, which the name already says. Hey, I'm exploring the broker on all my topics and data that is parsed through my broker. So as you see here, I have my TrueLaser 1030, and as you see underneath, I have all these different topics, and sometimes with subtopics, where data is constantly changing when it is reported by exception.
So that means, Len, that the MQTT broker actually shows the latest state of this machine.
Yeah, so this is the current state, as you say. It's the current state of the machine. So it's real time. Of course, it's a simulator, but it's real time showing the state as well as changes within that state.
Exactly. And the broker, other clients can subscribe to those topics, and they then will be informed as soon as a value changes.
Mm-hmm.
So that means that you have one central point, and you can fan out event changes or status changes to a variety of, for example, business processes and information systems or dashboards or whatever who wants to consume a status change.
Yeah, exactly. So when I move back to my presentation, because as we discussed, we have the simulator, the edge device that transfers it, which we just showed, and then Mosquito. It's running in the background, but the MQTT Explorer shows a little bit what is going around, so to say. And then I'm using, again, MQTT within Node-RED, which is on a different device, which is on a Raspberry, which is my home server, so to say. And within that Raspberry, I want to I have my broker running, which is getting all the information and parsing the information. I have also Node-RED running again for some transformation or parsing of the data. And I have Influx and Grafana running, because all that information that is parsing through my broker, I also want to database, because as Wim told me in the past, and I also, of course, seen in practice, all this data is a goldmine for the future, because using smart systems and intelligent systems upon that data can make, a proposal towards the future.
Yeah,
How do you say?
predict.
Can predict the future. So with that data, and if you want to go towards predictive, for example, predictive maintenance, etc., you need data to train the model to make that predictions. So one of the important points was database it, and then on top of that database, I want to visualize what is going on in the real-time state of my machine in a physical dashboard manner, so to say.
Yeah. So that means, Len, that actually you transform a message from the machine to an event. And what you actually did there is you invented an event that is the standard for your whole factory. And then it doesn't matter whether it's a true laser or a bending machine or a drilling machine or whatever. You standardize that. You transform that machine protocol to a standardized event that you publish on the broker.
Yep.
That standardized event is also stored in the database. That means that actually you have decoupled the way the information is stored from the way that the machine itself presented that information. And that means that you completely decoupled those two worlds, which makes you super flexible in the future. If you substitute the true laser with another model or with another brand, or you add other brands or whatever, it doesn't matter, because you have standardized your events.
Exactly. Which, as you said, makes you very flexible. And that's why we're also telling our customers, hey, try to find an open standard which gives you the flexibility, because the world is not, or there is no single factory to be found that has just a specific machines or systems, which only uses like one specific protocol, for example. And that's why we're using a protocol on top, which unifies that data transfer, so to say, which in this case we are using MQTT. Yeah.
And just for the listener, this now is a use case where we observe a machine, but it can be any business process. It can be your commercial business process. It can be your quality assurance business process. It can be your the stock, whether raw materials come in and go out, etc. It doesn't matter what it is. The mechanism is exactly the same.
Yeah. So I could also, let's say, in that case, if my offer that I made in Quotation Factory would go to the status order, for example, I could publish that also in my namespace. And for example, hook up another node to that based on that subscription then automates a different process, which is not operational, but more IT related, for example, IT automation. Yep.
Okay, great. Just very shortly, InfluxDB is the database. In the literature, that's also the function of that database is an historian, because it stores the history of all the events that took place or happened, the happenings. Yeah. Okay, go ahead.
And which also is important to add, it's time-based. So because if you want to predict or whatever, you need to know whenever that change was happening in a certain element of time. So this is also, and then we have Grafana for the visualization and dashboarding. So let me see. So as I said, Node-RED, I'm also running on my Raspberry as my local server, which then all the topics I subscribe to, the data is coming in when it's reported by exception, and I am parsing that data or transforming that data and then parsing that data into influx, which is the node that you see here, which is then my database. And I can show you a little bit about my database. As you see here, this is my data explorer, and you see a lot of different data points that are coming in and are stored, which are just values. I'm not sure if it's going to show something. Yeah. This is like more raw data, and to really visualize this more in a visual manner, I'm then using Grafana, which I will show you now. I made a basic dashboard. So first I wanted to show if my machine is running. So let's say my status light currently burning red. So my machine is not operational currently. I wanted to show like my machine state history. Due to the fact I started my simulator a little bit later this morning, it's not really filled, but you can see the different states in a timeline. So the history of that, as you can see, it has the data in regards to the sheet size. I see that one table is not working, but hey, it's an example. And I'm trying to measure, hey, what is my machine utilization? So how much percent of the time is my machine actually running? And how much percentage of the time do I have an error on my machine? And this can, as long as you have the data, you can visualize this. So this is just a visualization of a few data points, but of course you can go wherever you want as long as you have the data, so to say. Yeah.
Nice. Now, so actually it looks at the events, knows then how much time is idle time, how much is production time. That's actually the difference between the time between events. So that's the logic behind this dashboard.
Yep.
Yeah. And this dashboard also shows, because the machine has a lot of various statuses that it is in, and you turn that into a binary status. It's red or it's green.
Yeah, and we also have some yellow color. So it depends on the status. Yeah. The red is error or standstill. Yep.
Yeah. And then, of course, now you have a daily view or of the current day or the last 24 hours, something like that. Yeah. You can time travel if you want, and then it will show how it was in the past. Yeah. Okay, fantastic.
Yeah. As you see, so like my machine history, I'm only parsing 3 hours of that. And for example, my machine utilization is based on a 24-hour time frame. But you can even go, as Wim says, back to 1 year, for example, to see specific percentages like OEE or whatever you want to calculate. So that is the benefit of the timestamp.
Len, that means that, for example, this is, so now it's green, the machine, based on an event.
Yep.
Another microcontroller could subscribe to the same event, but then starts blinking a light on the machine or somewhere in your shop floor, indicating the problem as well. And then you have actually two clients with a different representation based on the same set of events.
Yeah, and the actual status of your manufacturing site. Yeah. Exactly.
So, or it could be a message to your WhatsApp app on your iPhone or on your cell phone. Sorry.
Yeah, we also played around with some testings where it sent a message to WhatsApp, where as the machine was standing still longer than 30 minutes, the production manager in this use case would then have a message on his WhatsApp, hey, machine is standing still for more than 30 minutes, check out the machine. Whereas you can also, for example, just every 24 hours send a report to a certain email address of the state of that machine or that production line. You can go, or let's say the options are endless in that sense. You can also say, if my parts are ready and it's coming out of the change table, for example, you can have a robot which can subscribe due to MQTT, for example, to the broker, and then whenever it's the sheet is finished running, that it starts for example, picking the parts out, so
Yeah.
it's also, so operational automation as well as IT, information technology automation. Yep.
Yeah,
Yep.
because it's really tens of milliseconds that an event will arrive at a client, for example.
Yep.
A client,
And
a consumer of the broker, I mean.
there's a lot of, or you can parse up to 10,000 to 100,000 events per second in the UNS. So, yep.
Two things. So Grafana is free, and the power of that is that you can quite easily create dashboards with all kind of widgets that are freely available. The same with Node-RED. The power, I think, of Node-RED is the variety of use cases that there are scripts for that you only have to configure. For example, sending it to WhatsApp or connecting it to something else. Or
there's a huge user base, and there are lots of developers that are developing like specific nodes that they developed due to their own use case, and then they're opening it up for the public. So you don't need to do all the coding and to understand what is going on the backside. They just open up this node. You can download it. For example, the OPC-UA connection, there is like a full palette of nodes available to do so. And it gets maintained in most cases. So due to the fact that it's used also in an industrial application. Yeah.
Exactly.
Which is very nice.
Great.
So all the software I used is free and open source. So which is really nice. And also is very interesting for maybe our customers in that sense that you don't need a high investment to get started with building a layer up on top of your existing software to start your digitization journey.
Exactly.
And at least playing around and understanding the concept, and then of course you can see what you need in a later sense, and that it might has you might pay for that, but be aware that you try to keep it open, because this gives you the flexibility.
Great.
Let me check.
Anything else to show?
I had like a short summary that it was interesting. I wanted to share. It's more like my lessons learned, which, as Wim already said, like it's accessible, so it's open, it's free, and as long as you're willing to invest the time, I think everybody can do it. Yeah, and especially with using tools like ChatGPT, when you're more like a OT guy and less of an IT guy. And the interesting thing is that you create an open source architecture that really can support smart manufacturing and Industry 4.0. And what I found really interesting is that you can build it on top of your existing architecture. So it's not that you have to say, hey, I'm just eliminating everything like this. No, you can build it on top and slowly try to connect everything to the next layer, so to say, and building that event-driven architecture. And then we already discussed the low cost solution, and that it is industry ready. So there are multiple worldwide use cases to be found, which is really interesting and nice to see, because that also gives the feedback that you can trust this open source technology, then that it's ready then for more than just the use in a hobby environment, for example. That is most of the time seen when they talk about open source software. They say, oh, it's open source and therefore it cannot be used industrial. But this is definitely not the case.
Maybe one additional thing, because that's true. The software that you use is open source, but that open source is also based on open standards, worldwide standards. You can have a vendor selling something, but for example, an MQTT broker, you can buy one, but then at least it's based on an open standard, which is MQTT. So the fact that we use standard protocols is even more important than the fact that it is open source.
Exactly. I'm fully agreeing there. Yeah, it's a good side note.
Good.
Good.
Can I ask you a couple of questions?
Sure,
If
Wim.
this is the presentation and the end of
Yes.
the presentation.
Yes, we can close off the screen. I think. Let me see. StreamYard. Yes.
I stopped the screen sharing. Yeah.
Perfect.
So, for example, you mentioned at the start of your presentation the ISA 95 standard, which is a beautiful standard, by the way, with a lot of really clever people in the field were involved in creating the standard. But one of the things is the ISO 95 pyramid, where you see the ERP at the top and, for example, the PLCs at the bottom, somewhere in between, blah, blah, blah. And the way that model often is interpreted is that there's a vertical integration between all those layers. What you see with an event-driven architecture is that you can create all kinds of integrations based on the broker. So it's no longer a strictly vertical integration. You can integrate whatever you want, wherever it is in the abstraction layers of that ISA 95 stack. What is your... Often we see that our clients or customers position the ERP system as the central database and the central, the truth of the factory. Now we see events and an historian. Does that role change then?
From my point of view, yes, because in some way it depends on how you want to what your strategy is. That is the first thing I would like to say, because I think what we try to do with the ERP system over those last 10 years is try to create that single source of truth, so to say. And what we had at the time was the ERP system that had like the most wings into how do you say the MES part of things, into process, into sales, for example. All that information was brought together into the ERP, and we tried to do way more, I think, in that ERP that it was ever intended to do. So from my point of view, that was the best that we had at the time. And now we have somehow, or at least this is my personal opinion, an architecture which offers more flexibility, more open standards. And that is also where the ERP system is, most of the times it's a closed black box. So and it's not really easy to connect stuff to that. And then you get a point-to-point connection. With then if you are extracting that, you have to redo all the development work that you have been doing, put in a ton of money again, and this is something that the unified namespace or the event-driven architecture is eliminating. So, I think therefore you would the ERP is going to be there, and it has a good function and a lot of different topics, but I think it was never intended to put everything in and try to do everything into the ERP system.
I agree. So the historians becomes your gold mine. The historian, becomes your gold mine because that has all the history. If you look at your ERP system and, for example, the log that it generates, you can often recreate the events of the past. You can do that from your ERP system or other information systems that you use, and look at logs and the database, what's in there, and then you can recreate events of the past. So that's also, I think, often very valuable.
Definitely. And I think this is also, you have these dashboarding tools also into your ERP system, but I think also the benefit of having one layer above is that you connect everything to there, because some things cannot be connected or stored into the database of the ERP system, and then you will have multiple solutions trying to dashboard for a specific reason. And this is also something which is making this possible. So you have the single source and the single dashboard environment where you can create thousands of dashboards depending on your needs.
Yeah. Now, Len, I'm getting a little bit dashboard. How do you say that? What's the right word for this? I always hear dashboard, but that for me is not smart yet. So in the next couple of live streams that we are going to do, we are going to show how to bring in intelligence that helps you get to that level of becoming a smart factory.
Nice. Because that is, now we're like evaluating as a person the dashboard and then taking action into the factory to change. And this is something, it's a first level of smart, but I think it's not the level of smart that we are.
It's still a closed loop where the human has the autonomy, but not the system itself. And we want to go to, what is it? A dark factory, huh? Or
lights out factory.
Lights out factory. Yeah.
Yeah, which is fully autonomous. Doesn't matter the time,
Okay. Hey, was it frustrating to work on this, or did you have a lot of fun? How did you?
For me personally, it was a lot of fun because it was something which I was like, I always used it, like the elements, so to say, but I was never able to really make something. Yeah, because I was always depending on vendors or integrators that needed to fix my solution, which is really satisfying because I don't like to be dependent on people, which is one thing. Secondly, for me, it opened up a new world. So, and I like to learn, I like to discover. So this is something that really made me very enthusiastic as well. And it was nice that I don't needed a ton of know-how to get quickly to a point of first satisfaction stuff moving around, and so that was really nice for me personally. I really enjoyed it.
Nice to hear, because that's the thing. We are, as Quotation Factory, we develop software, so especially our software developers deal with events all day, so they really have a good understanding of what it means. And now we talk very positive about it, but also it has a lot of negative side effects, which we will deal with later in later videos. But especially the customer success team, I think they also should have that experience. And this is a great way to not only understand it conceptually, but really have felt it. It's like you want to play piano and you can read 1,000 books, but that doesn't make you a great piano player. You have to sit there and make your hours.
Do it.
Let's say. Yeah, do it.
Yeah, and I think this is also what I really like that you pushed us in that sense, is because this is a transformation our customers are going to be going through over probably the upcoming 5 years or even longer, and really understanding it and being capable of maybe not really advising, but understanding their difficulties and understanding where they might go to also focus a good solution. And to form a good solution for their needs in relationship to our platform that we are building. And it's becoming more of a whole. Like previously it was like we could containerize everything very easily, but due to the movement into the smart factory, everything has to be connected. So it has to be talked together. So therefore you need a more holistic approach and not only looking very containerized.
Exactly. Great. I think that this was really, we have done this in Dutch before, but with a lot of echo. We solved that. The story is great. The use case, really well done, Len. Thank you for that.
Thank you.
I think one of the next use cases you are going to show is with an actual device as well, huh?
Yeah. So in my spare time, I have some machines in my basement. So from laser cutting to milling, and also Wim said, hey, try to apply the know-how and try to also integrate some electronics, microcontrollers and sensorics because you might want to observe or put something into your namespace where you don't have the sensoric currently, but due to the fact like mobile phones, etc., are so accessible these days, and its technology has grown so easily, all these sensors and stuff are so cheap, and this technology is so cheap that you can generate a lot of input really easily with, like, for example, with €7, you have something that can evaluate temperature, humidity, send that to through Wi-Fi to a network, and it's just €7. So I try to make my devices in my basement smart and connect them to my UNS. So I will show another time.
Okay, great. I haven't seen it yet, so I can't wait to see it.
Nice. Let's do
Okay,
it.
well, let's finish up this live stream then. Thank you, Lenn.
Thank you, Wim.
I'm really curious what kind of comments or feedback we will receive. Again, it's meant as inspiration for all manufacturers and especially metalworking factories, for example, our customers. If you work towards this architecture, our customer support team is always open to discuss and share ideas. And for us, the super use case is obtaining your simulated times as well as real production times in order to help you become as realistic with your estimations as humanly or automatically possible. Yeah? Thank you, Lenn.
Thanks again.
Hey,
Till next time. Ciao.
Hey, bye-bye. Ciao.